Hello class, welcome to this video on Unit 4 FRQ. So we took a quiz on this for Unit 4. So let's go ahead and take a look at the free response questions. So grocery store purchases melons from two distributors, J and K. Distributor J provides melons from organic farms. The distributions of the diameter of the melons from distributor J is approximately normal, with mean of 133 millimeters and standard deviation 5 millimeters. For a melon selected at random from distributor J, what is the probability that the melon will have a diameter greater than 137 millimeters? Okay, so they're talking about just distributor J, and they said distributor J is approximately normal. So we know that, it's since it's approximately normal, something like this, right? And we know that the mean is 137 or 133, and the standard deviation is 5. So that means it goes by 5s. So we got 138, 143, 148 here. And then we're going by 5s here. So 128, 123, 118. And we want the probability that it's greater than 137. So we want this 137. So it's going to be area to the right. So we want the probability that x is greater than 137. Now you can calculate the z-score. So you can see, okay, so this is the probability that z is greater than what? So you can calculate the z-score, which is x minus mu divided by sigma. And so here we got 137 minus mu is 133 divided by sigma, which is 5. And so we get 4 over 5. Which is 0.8. And so you can say, okay, the probability that z is greater than 0.8, and you can look this up in table A, or you can use your normal CDF function, right? So you can also use that and get the answer. So we'll use our normal CDF function, in which case we got lower. Now, since we're using the normal CDF function, it's good to have a graph just so that they can visualize the region and all that stuff. So we got lower. So the lower region is 137. Our upper is infinity, so we're just going to say we're going to say 1,000 or something like that, or 10,000. And then we got our mean, which is our mean. So now, for this, you can use a couple of things. You can use a mean of 0, and then a standard deviation of 1 here. Or if you did, then you would have to use a z here of 0.8. Okay. So I'm going to put two possible options that you could put. Okay, you can put 137, that's not 13.7, that's 137. And then you would have to put in that case, you would have to put mean of 133 and standard deviation of 5. Or you can use normal CDF. So you don't have to put both of these, just put one of them. You could do, the lower has to be then the z-score, which is 0.8. The upper, 10,000. Then you would have to put the mean of 0 and standard deviation of 1. Okay. All right. Technically, the normal CDF, this one's easier. This one tends to be more accurate, but still, they tend to be very similar. Okay. So either one will be fine. So either way, you would get approximately, depending on which method, 0.2119. All right. Okay, so the next one, distributor K provides melons from non-organic farms. The probability is 0.8413 that a melon selected at random from distributor K will have a diameter greater than 137. For all the melons at the grocery store, 70% of the melons are provided by distributor J, and 30% are provided by distributor K. All right, so we're going to say the event J is you have melon from distributor J, because we're gonna use a tree for this. It's nice to use a tree for this because you can organize it. Melon from distributor K, and I'm going to use D for diameter greater than 137. Okay, so we'll do something like that. Okay, so now if we set up a tree diagram, we got J, we got K. So then the probability of J is says 70% of the melons provided by distributor J. So probability of J is 0.7. And then we got 30% are provided by distributor K, so probability of K is 0.3. And then we have, let me put this in a box here. So then we got, okay, so now if 70% are from J, and then they're either going to be greater than or not greater than 137, right? Because we want the probability that the melon will have a diameter greater than, but we're going to just kind of show you both. This is just to kind of organize it for you guys. And then just put G prime. Or I put D for greater, sorry about that, instead of G for greater. And then D prime. Okay, and then and this we said was, so this is the probability that is greater than, the diameter is greater than, given that it came from J. And then the probability not, given J, and so on and so forth. All right, now, so we want basically the probability that that melon will have a diameter greater than 137. But so if we want greater than, that means we want these two, this one and this path, right? Or wrong one. That we want those two pathways. So we want pathway number 1, which is this pathway. And we want pathway number 2, which is this pathway. All right, so let's go ahead and do that. And let's label these while we're at it. So the probability that its diameter is greater than, given J, well, we just calculated that, 0.2119, right? So we're going to use that here. So this is 0.2119. And if that's 0.2119, this is 1 minus that. All right, and then this probability here, the probability of K, D given K, well, they said here for all of the melons of the sower, it says the probability is 0.8413 that the melon selected at random will have a diameter greater than. So that's this one right here. And so this is 1 minus that. Okay, so we don't care about those other pathways though. We only care about 1 and 2. So we're going to combine the probability of D is going to be pathway number 1 plus pathway number 2. And so now that means I have to do the probability, I have to multiply these two together. So I have to do 0.7 times 0.2119, which is pathway number 1, plus 0.3 times 0.8143, which is pathway number 2. All right, and that's what we're looking for. So then we would have to just add those together. And so when we do that, and we probably want to label this, right? So let me label this. So this is, let me label these things. So this is J and D plus probability of K and D, all right, which is that. All right, and then we would get 0.1483 plus 0.2524, which is 0.4007. All right, and then part C, given that a melon selected at random from the grocery store has a diameter greater than 137, what is the probability that the melon will be from distributor J? All right, so it's so the probability given, given that it's greater than, or D, greater than diameter, that's we said event D is that, and then we want it from B distributor J. So the probability of J given D. So remember the formula for conditional is the probability of both divided by the probability of the given. All right, and we just calculated the probability of the given, or of the given here, 0.4007. So we don't have to do that again. And we know J and D comes from the tree diagram. So J and D, which is this first part, 0.7 times 0.2119, right? And we know, yeah, so we can do that from the tree, okay? All right, and then we got this one is 0.4007, and so we can get 0.1483 divided by that. This is from pathway number 1 in the tree. Let's see, is it pathway number 1? Yeah, pathway number 1, J and D. 0.3701. All right, that's it, guys. That's going to do it for the video. Hope you found this useful and informative as usual. I'll see you in the next one.